All right, let's dive into a really fascinating paradox in the world of AI. What if the one thing we think makes an AI so powerful, its perfect memory, is actually its most crippling weakness?
We always think of perfect recall as this incredible AI superpower. But imagine what happens when that AI remembers everything. I mean, every single dead end, every little coding error, every useless piece of data it's ever seen. It doesn't become a super genius, it gets paralyzed.
And this right here is what researchers are calling the monolithic agent problem. Just picture a digital hoarder. This kind of AI just passively records every single thing it comes across, and it piles it all into one giant, messy digital room. It never cleans up, it never organizes, and this is the critical part, it never, ever forgets.
Now, this hoarder AI, it runs into this three-part crisis. First up, you get token bloat. Its workspace gets so cluttered with junk data that it just gets slow and super expensive to run. Then, task alignment decay kicks in. The AI literally gets lost in all that noise and forgets what it was supposed to be doing in the first place. And finally, it hits executive paralysis. It just can't tell the difference between a big picture strategy and some tiny trivial detail. It's completely and totally overwhelmed.
So how do you fix a hoarder? Well, you don't give them more storage space, right? You teach them how to curate. And that's the absolute core of the solution here. Building an AI that thinks less like a hoarder and a whole lot more like a museum curator.
And this slide just lays out the difference perfectly. The hoarder, it just records everything, leaving you with this cluttered mess. But the curator, it actively manages information. It doesn't just store data, it structures it. It filters out all the noise and it zeroes in on the important signal. It's a huge shift from just remembering to actually understanding.
Okay, so the actual tech that pulls this off is a system called AegisNet, and it's guided by this incredible co-pilot brain called MemoBrain. So instead of just one AI trying to do everything, they work like a team. MemoBrain is basically the executive, the boss, that's actively managing the memory for the main AI.
So how does this whole curator model really work? I mean, what's in its secret toolkit? Let's break down the 3 core moves that give it such an intelligent and almost unfair advantage.
It's a beautifully simple 3-step process. First, it does a flush. It finds and just throws out all the junk data, all the failed attempts and dead ends. Gone. Second, it uses collapse. It takes a long, complicated task it just finished and boils it down into one simple, useful conclusion. And finally, it uses a smaller, faster AI to rank information, basically pre-sorting what's important before the main AI even sees it.
And here's a perfect example of that collapse function in action. The system can sift through 10,000 tokens of messy, raw network data, we're talking pages and pages of text, and just distills it all down to one single essential thought. Resolved. Target identified at 192.168.1.1. All the noise just vanishes and only the crucial meaning is left.
So, what happens when you stop hoarding and start curating? The results? Well, they're not just an improvement, they are a total breakthrough. The performance gains are just staggering.
Just let that number sink in for a second. A 90% reduction in token bloat. That massive, cluttered workspace that was crippling the old AI, poof, it's practically gone. The system is leaner, it's faster, and it is so much more efficient.
And that efficiency, it translates directly into success. The old monolithic system, it only succeeded at its tasks about 42% of the time, which means it failed more often than it succeeded. But AegisNet, with its smart executive brain, jumps to a success rate of almost 77%. It's not just a little better, it's vastly more reliable. And the economics of this are just a total game changer. Look at this. The context window shrinks from a huge 128,000 tokens down to a super manageable 12,000. The success rate, as we saw, nearly doubles. And what does that mean? The cost per task absolutely plummets. You are getting way better results for just a fraction of the computational cost. Okay, so what does this all look like in the real world? The researchers put this new system through the ultimate test, asking it to think creatively about cybersecurity threats, a task that demands long-term planning and an incredible ability to separate signal from noise. They use this dataset called ThreatSciFi, which throws these really complex creative challenges at the AI. A prompt like this one, plot a zero-click chain escalating to kernel RCE, is basically asking the AI to invent a sophisticated cyber attack that can take over the very heart, the kernel, of a computer system without the user doing anything. A hoarder AI could never, ever handle something like this.
And look at this performance difference. On one specific task, the old monolith system would churn away for 45 seconds, just trying to make sense of the raw logs to find one vulnerability. AegisNet, using its smart memory, did the exact same thing in just 4 seconds. That's not just faster, that is a completely different league.
So what's the big picture here? What is the key takeaway from all of this? We're really looking at a fundamental shift in how we should be thinking about building powerful AI systems.
I just love this metaphor from the source material. We're moving away from the backpack of the monolith, where the AI is just weighed down by every single piece of data it's ever collected, and we're moving towards surgical intelligence, where the AI carries only the precise tools and the exact information it needs for the job at hand. Nothing more.
This quote really gets to the heart of it all. The goal isn't perfect total recall of raw data anymore. The new goal is to understand and remember the meaning behind that data. And that is the difference between just hoarding information and actually possessing true knowledge. And that leaves us with a pretty provocative final thought to chew on. Maybe the next great leap forward in AI won't come from building bigger and bigger memories, but from building much, much smarter ones. Because the most intelligent systems, whether they're human or artificial, aren't the ones that remember everything. They're the ones that have mastered the art of knowing what to forget.